10 days before a single person on Earth knew this object existed, it was already sitting inside a telescope's memory, unnoticed, waiting to be found. The gap between when it was actually photographed and when anyone realized what they were looking at is the real starting point of this story. And by the end, you'll understand why two of the most powerful telescopes ever built, James Webb and the Vera C, Rubin Observatory, both ended up staring at the exact same object without either team planning it that way. On July 1st, 2025, a survey system called ATLAS, short for the Asteroid Terrestrial Impact Last Alert System, spotted something moving through the solar system from a facility in Rio Hurtado, Chile. At first, it got a plain technical label, C2025N1. Within days, astronomers confirmed something far more significant. This object hadn't come from anywhere inside our solar system. It had arrived from interstellar space from somewhere entirely outside the sun's gravity, and it was only the third such object ever confirmed in recorded human history. It was named 3I Atlas, and observatories around the world turned toward it almost immediately. Here's where it gets genuinely strange. A few weeks after the official discovery, scientists working with the brand new Vera C Rubin Observatory in Chile went back through their own archived data, doing routine housekeeping, checking old test images from a calibration phase called science validation. And there it was, sitting quietly in the background of images taken on June 21st, 2025. 10 full days before Atlas ever announced the discovery, 3I Atlas had already been photographed. Nobody at Rubin knew it was there. The telescope wasn't hunting for interstellar objects that night. It was simply testing its systems, pointed in a direction that happened purely by chance, to include the exact patch of sky where this ancient visitor was quietly passing through. Rubin kept accidentally photographing the object all the way through July 20th, 2025, collecting nearly 100 exposures in total, and researchers eventually used 49 of those images in a full scientific study. That makes Rubin's images among the earliest and highest resolution pictures of 3I Atlas that exist anywhere on Earth, captured entirely by accident before most of the world even knew the object was real. What did those accidental images actually show? Quite a lot. The data revealed a growing coma, a cloud of gas and dust surrounding the comet's core, and that cloud expanded by more than 50% during the observation window as the object moved closer to the sun and began heating up. Completely normal comet behavior on its own. But there was one detail that genuinely surprised scientists. The object had a dust tail pointing toward the sun instead of away from it. Under ordinary circumstances, a comet's tail points away from the sun because sunlight physically pushes dust particles backward. A sunward-facing tail is rare, though not unprecedented. Researchers have documented a similar effect in at least one other distant comet before. Scientists explain it through something called anisotropic dust emission, meaning the dust wasn't being released evenly in all directions from the surface, which can produce unusual tail shapes depending on the viewing angle. Strange, yes. But explainable science, not an unsolved mystery. Before going further into the chemistry, it's worth understanding exactly what kind of instrument managed to catch this object by pure accident. The Vera Rubin Observatory sits on a mountain called Cerro Pachon in Chile, chosen specifically for its dry air and dark skies, ideal conditions for observing faint objects deep in space. Its main mirror is 4 meters wide, roughly the length of a tennis court, paired with the LSST camera, the largest digital camera ever built, capable of capturing 3,200 megapixels in a single image. At the moment it photographed 3I Atlas, the observatory hadn't even officially begun its real mission. It was still in a testing period, essentially a dress rehearsal where engineers check every part of the system, the optics, the camera, the software pipelines, before the actual 10-year survey begins. During that phase, the telescope points at various patches of sky purely to test image quality and calibration accuracy, not to hunt for specific objects. That's exactly why nobody realized 3I Atlas was sitting inside these test images for weeks after they were taken. Researchers only found it after the official discovery, when they went back through the archived commissioning data specifically to check whether it might have shown up early by coincidence. It had, hiding quietly in the background of ordinary calibration frames, 10 full days before the rest of the world knew to look. Here's the detail that shows just how precise this accidental discovery actually was. Rubin captures images across 6 different filters covering different colors and wavelengths of light. Scientists measured the object's position across all of these bands with a typical precision of about 70 milliarcseconds, an extraordinarily tiny angle given how faint and distant the object was at that point. For comparison, Rubin's precision on fixed, unmoving background stars is even sharper, closer to 3 milliarcseconds, so the slightly coarser precision on 3I Atlas simply reflects the difficulty of tracking something actually moving relative to the background sky. This level of detail allowed a research team led by astronomer Colin Orion Chandler, working with more than 300 collaborating scientists to publish a full paper analyzing the object's precise position tracking, brightness, shape, and activity level, based entirely on this accidental early data. Now here's where the story connects to Webb. On August 6, 2025, the James Webb Space Telescope turned its near-infrared spectrograph, called NIR-SPEC, directly at 3I Atlas. This was Webb's first real look at the object, following observations already made by Hubble and NASA's SPHEREx mission. Rubin's job had been photographic, shape, brightness, movement. Webb's job was different. It used spectroscopy to break the comet's light apart and read its chemical composition, almost like a fingerprint. And Webb found something unusual, almost immediately. Inside the comet's coma, scientists detected carbon dioxide, water ice, carbon monoxide, and a pungent compound called carbonyl sulfide. Fairly ordinary comet ingredients on their own. But the ratio of carbon dioxide to water was the highest ever recorded in any comet ever observed, whether from our own solar system or from interstellar space. That ratio matters because it tells astronomers something about the environment this object originally formed in. Different formation temperatures and different amounts of ambient sunlight produce different chemical ratios inside a forming comet. Then, in December 2025, Webb looked again. As 3I Atlas made its closest pass by the Sun on October 29, 2025, a moment astronomers call perihelion, the comet's ancient ice began rapidly turning to gas, producing a brighter, more active coma that was perfect for detailed observation. Webb captured this second, deeper look on December 22, 2025, right after the object made its closest approach to Earth on December 19th, passing at a safe distance of roughly 168 million miles, about 270 million kilometers, posing zero threat to our planet at any point. In the second pass, Webb measured something even more revealing: specific ratios of carbon and deuterium, sometimes called heavy hydrogen, locked inside the comet's ice. These exact ratios don't match anything found in comets that formed inside our own solar system. Working backward from that chemical signature, researchers estimated where and when this object was actually born, and the answer was staggering. Based on Webb's data, scientists calculated that 3I Atlas likely formed somewhere between 10 and 12 billion years ago, in a cold, distant region of the early Milky Way. For comparison, our own solar system, including Earth, the Sun, and every planet we know, is only about 4.6 billion years old. That means the ice and dust making up this comet were already drifting through space, frozen and unchanged, for billions of years before our own sun had even finished forming. Some researchers have pointed out this makes 3I Atlas nearly as old as the universe itself, estimated at roughly 13.8 billion years. This research was formally published in the journal Nature on June 22, 2026, after passing peer review, meaning independent scientists checked the data and conclusions before publication was allowed. So here's the honest answer to the question a lot of people online keep asking. Is this the terrifying alien object some corners of the internet keep insisting it is? No, scientists have been extremely clear and consistent about this, and it's worth walking through exactly why they're so confident rather than just taking their word for it. First, the object behaves exactly like a comet is expected to behave, developing a coma as it approaches the sun and releasing gas and dust in a pattern that matches physical models built from decades of studying comets inside our own solar system. Second, the chemistry Webb detected, carbon dioxide, water ice, carbon monoxide, carbonyl sulfide, are all completely ordinary comet ingredients. The same basic building blocks scientists have already cataloged for decades in comets that formed right here in our own solar system, just present in a different ratio, which speaks to temperature and formation conditions rather than anything artificial or engineered. Third, the object's trajectory follows the predictable laws of gravity and orbital mechanics, with no unexplained deviations, no sudden changes in speed or direction that can't be explained by ordinary outgassing. The same kind of small course corrections comets have shown for as long as we've been tracking them. Every measurement, from Rubin's early accidental images to Webb's detailed chemical analysis, points to one conclusion. This is a completely natural interstellar comet made of ordinary ice, gas, and dust, just like the comets already studied inside our own solar system, only far older and arriving from somewhere entirely outside it. Astronomers have said directly that the evidence rules out an alien probe and that framing it that way actually undersells how genuinely remarkable the real science is. Because think about what this object represents. It's a physical sample, a real chunk of frozen material from another region of the galaxy entirely, from a time before our own sun existed and before Earth had ever formed, that happened to drift close enough for our telescopes to study it in detail. Researchers have compared the opportunity to finding a message in a bottle that's been floating across an ocean for billions of years. Except here, the ocean is the entire galaxy, and the bottle is made of ancient ice instead of glass. That isn't science fiction. It's one of the rarest natural events astronomers could ever hope to witness in their careers, and it happened at the exact moment humanity had some of the most advanced telescopes in history pointed at the sky. It's worth understanding why this particular chemical signature was so useful for pinning down the object's age. Deuterium, heavy hydrogen, is a slightly heavier version of a normal hydrogen atom, and the ratio of regular hydrogen to deuterium found inside ice acts almost like a chemical clock. That ratio changes slowly and predictably based on the temperature and radiation conditions present when the ice first formed billions of years ago, and whatever cold, distant cloud of gas and dust eventually became this comet. By carefully measuring that ratio with Webb's near-infrared spectrograph, researchers could work backward and estimate not just how old the ice is, but roughly what kind of environment it originally formed in, something scientists call galactic chemical evolution. Our galaxy has been slowly changing its own chemical makeup over billions of years, as generations of stars have lived, died, and seeded space with heavier elements. So an object formed extremely early in the galaxy's history carries a subtly different chemical fingerprint than something formed more recently. That's exactly the kind of signature Webb was built to detect, and exactly why an interstellar object like 3I Atlas is such a valuable target. It's essentially a frozen time capsule from an era of the galaxy no telescope had ever been able to sample directly before now. Let's put more numbers on the table because the scale of this object is genuinely impressive on its own. 3I, in which Atlas is only the third interstellar object ever confirmed passing through the solar system, and comparing it to the first two shows exactly why scientists are so excited about this particular visitor. The first was Oumuamua, discovered in October 2017 by a survey telescope in Hawaii, unusual for its strange elongated shape and a small, unexplained acceleration as it left the solar system, something that briefly fueled speculation online, though most astronomers concluded it was most likely caused by gas venting off its surface, a natural process that was simply hard to directly observe, given how faint and distant the object already was by the time telescopes caught up to it. The second was Borisov, discovered in 2019 by an amateur astronomer in Crimea, which behaved much more like an ordinary familiar comet, complete with a visible tail and coma, making it easier to study and compare against solar system comets. 3I Atlas is the third, and in some ways the most extreme of the three. Its orbit is far more hyperbolic, meaning far more sharply curved and open-ended than either of the previous two. Scientists measure orbital shape using a number called eccentricity, where a value of exactly 1 marks the boundary between an orbit that eventually loops back and one that never returns. 3I Atlas has an eccentricity of about 6.14, an extremely high number confirming that this object was moving so fast on such a wide-open trajectory that it was never gravitationally bound to the sun at any point. It was traveling at roughly 137,000 miles per hour, about 221,000 kilometers per hour, as it approached the inner solar system, an almost incomprehensible speed that leaves no doubt this object originated somewhere else entirely, passed through briefly, and is now leaving again permanently, on a one-way trip that started somewhere else in the galaxy, and will end somewhere else entirely, long after it leaves our cosmic neighborhood for good. Based on its speed and trajectory, researchers calculated a kinematic age, essentially an estimate of how long the object has likely been drifting through interstellar space, landing somewhere between 3 and 11 billion years, a range that lines up closely with the separate chemical age estimate that came later from Webb's data. Researchers have also noted that statistically, it's extremely unlikely this object has passed anywhere near another star as closely as it just passed our own sun, meaning our solar system may be the closest stellar encounter this ancient traveler has had in billions of years of drifting alone through the emptiness of the galaxy. Hubble Space Telescope observations helped scientists estimate the size of the object's solid nucleus, placing it somewhere between about 440 meters and 6 kilometers wide, a fairly wide range because measuring the exact size of a small, distant, actively outgassing object is genuinely difficult even for the best instruments, since the bright surrounding coma of gas and dust tends to hide the true edges of the solid core underneath. On top of Hubble, Rubin and Webb, other missions joined the effort too, turning this into one of the most heavily observed objects in recent astronomical history. NASA's SPHEREx mission observed infrared light from the object's coma, detecting dust, water, organic molecules, and carbon dioxide, adding another layer of confirmation using a completely separate instrument and wavelength range. NASA's TESS mission, normally used for hunting planets around other stars by watching for tiny dips in starlight, was redirected for a special observation run specifically to study the comet's activity and rotation, an unusual but valuable use of a telescope, not originally designed for comet science. Even a European spacecraft called JUICE, currently on its way to study Jupiter's moons, managed to capture an image of 3I Atlas in November 2025, simply because it happened to be in a useful position along its own separate journey through the solar system. So why does it matter that Rubin and Webb both ended up looking at the exact same object? Because together they represent two completely different but equally powerful ways of studying the universe. Rubin is built for speed and coverage, constantly scanning huge sections of sky, which is exactly why it accidentally caught 3I Atlas in the first place, simply by testing its systems in the right place at the right time. Webb is built for depth, for extremely precise observation of one target at a time, which is exactly how it pulled apart the comet's chemistry down to individual molecules and isotope ratios. One telescope found the object first, completely by accident. The other figured out what it actually was, where it came from, and roughly how old it is. Neither discovery would mean nearly as much without the other. This also says something about where astronomy is heading right now. The Vera Rubin Observatory officially began its 10-year survey of the sky, called the Legacy Survey of Space and Time, on June 30th, 2026. Its entire purpose is to scan the sky repeatedly every few nights for an entire decade, catching exactly these kinds of unexpected objects, asteroids, comets, and rare interstellar visitors, often before anyone else even knows to look for them. The fact that Rubin managed to accidentally photograph an interstellar comet before it was even officially discovered, while still in its testing phase, months before its real survey even began, is a genuine preview of what this observatory will be capable of once it's fully running night after night for the next decade. Scientists expect more interstellar objects to be found as the survey continues, and there's a real chance Rubin will be one of the first instruments on Earth to spot them, simply because, unlike almost every telescope before it, it never stops watching the sky. Meanwhile, Webb continues doing exactly what it was built for, taking whatever gets discovered, wherever it came from, and breaking its light down into the chemical evidence that reveals where it was born and how old it is, made possible, because Webb operates roughly 5 million kilometers from Earth, away from the heat and light interference of our own planet, letting its infrared instruments detect faint signals that would otherwise be lost to ground-based telescopes. Right now, 3I Atlas has already passed its closest point to the Sun and to Earth, and it's moving back out of the solar system, heading into deep interstellar space again quietly and permanently. Scientists kept gathering data as long as the object remained observable, coordinating across ground-based telescopes, space telescopes, and even a spacecraft en route to Jupiter, squeezing every last bit of usable information out of this brief one-time visit. What we're left with is a genuinely remarkable scientific record. A comet born 10 to 12 billion years ago, drifting quietly through the galaxy for almost the entire history of the universe, before briefly and completely by chance, crossing paths with a handful of human-built telescopes on a small, quiet planet, long enough for us to photograph it, analyze its chemistry, and calculate roughly how old it is before it disappears again, likely never to be seen by human eyes or instruments again. Not an alien object, not a threat, something arguably far more impressive. Direct physical evidence from a completely different corner of the galaxy, formed before our own solar system even existed, confirmed independently by multiple world-class telescopes working separately from each other, one of them purely by accident, simply because it happened to be pointed in the right direction on an ordinary test night. It's a reminder that some of the biggest discoveries in science don't come from searching harder. They come from having good enough instruments, running often enough, that when something this rare finally drifts past, we're already there to catch it.